Yes, in the last class we have studied about various measures of central tendency and measure of dispersion. In measure of central tendency you have mean, median and mode, and measure of dispersion we have standard deviation, mean deviation, quartile deviation and coefficient of them. So, next is skewness. See, when we take normal distribution, mean is equal to median is equal to mode, means all three measure of central tendency coincidence in the same line. But when we talk about asymmetry, so in that case we do not have the symmetry between mean and median and mode. So, if we consider skewness, so it gives the lack of symmetry, means asymmetry formation with respect to the frequency distribution. So, if we consider normal distribution, frequency distribution exists like mean is equal to median is equal to mode, whereas if we consider asymmetry, then in that case mean is not equal to median and median is not equal to mode. So, here we can see this distribution. So, this distribution is symmetrical distribution, or you can say normal distribution, where you have a bell shaped curve. In this case, mean, median and mode, all measure of central tendencies located in the same place in the center, that is mean is equal to median is equal to mode. But when we say asymmetry, then mean is not equal to median, median is not equal to mode. There will be a asymmetry in the frequency distribution. So, in the skewness we have two types of skewed distribution. One is positively skewed distribution and another one is negatively skewed distribution. When we take positively skewed distribution, we can see here the mode and median and mean is not located in the same point. It is distributed towards either right side or left side in general. If we consider positively skewed distribution, then these are located for the right side of the distribution, that is normal curve. So, here you can see the mean is the maximum, median is mode is least and median is in between mode and mean. So, when we consider negatively skewed distribution, this located in the left side and here mean is least and mode is maximum and median lies between mean and mode. So, if we consider skewness, we have three types of measurements under skewness, namely Karl Pearson coefficient of skewness, Bowley coefficient of skewness and measure of skewness based on the moments. Let us see one by one. So, this is about Karl Pearson coefficient of skewness. So, the skewness is the difference between mean and mode under this Karl Pearson. So, when we take two different measurements, say height of the person and weight of the person, we have two different units. If we consider height of the person, it would be in feet or inches. If we consider weight of the person, then it is in kilograms. So, when we compare these two parameters, we can't compare it because we have two different measurement of units here. That is why in order to compare these two, we should not take absolute measure of dispersion, but we will have to consider relative measure of dispersion, that is nothing but coefficient of skewness. That is Karl Pearson coefficient of skewness is given by mean minus mode divided by standard deviation. Suppose in case of mode is absent or mode is nil or mode is 0, then the coefficient of skewness under this Karl Pearson is 3 into mean minus median by standard deviation. Let us see this example under ungrouped data, that is individual series. Individual series means we have already studied this one under measure of dispersion, that is when we do not have frequency there, then it is considered as individual series or ungrouped data. So, calculate the Karl Pearson coefficient of skewness for the following data. Here you have a data or size, it is in ungrouped data or raw data you can say. So, you will have to calculate the Karl Pearson coefficient of skewness. So, for that we can take this given data. So, you can start with the solution here. So, computation of mean and standard deviation. So, here you can calculate this mean and standard deviation by assumed mean method, deviation from assumed mean method. For that you will have to take size, that is given data 25, 15, 23, 40, 27, 25, 23, 25, 20. So, take deviation from assumed mean here. I am going to take 25 as assumed mean, then you will be getting d value, that is x minus a. So, take 25 minus, this is constant value a, 25 minus 25, 15 minus 25, 23 minus 25, like that you will have to solve the deviation from mean value. So, you will be getting the values like 0, minus 10, minus 2, plus 15, 2, 0, minus 2, 0, minus 5. So, take the summation value here. So, summation d is equal to minus 2. After calculation of this d, you will have to square them, that is 0 square minus 10 square, like that. So, 0, 100, 4, 225, 4, 0, 4, 0, 25. So, here you will have to get summation d square value is equal to 362. So, summation d is equal to minus 2 and the summation d square is equal to 362. So, now you can calculate the value of mean, that is x bar, and standard deviation value by using a, d and n values. Here n is nothing but number of variables here. So, how many variables here we have? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, n is equal to 9. Take a is equal to assumed mean value, which you have already taken here, that is 25. Take summation d value, that is minus 2 divided by n, that is 9. So, that will give you 25 minus 0.22. So, finally, we will have to get the value 24.78. So, this is the mean value 24.78. Let us calculate the standard deviation here. So, take summation d square by n. So, summation d square here 362, take that value, 362 by n minus summation d, that is minus 2 by 9 whole square. Then you will have to get 40 plus 22 minus 0.05. So, that is 40.17. So finally you will have to get standard deviation value is, that is sigma value is 6.3. Like this you will have to calculate the mean and standard deviation value. After calculation of mean and standard deviation value, we will have to take the Karl Pearson coefficient. For that we need, here mean we need, mode and standard deviation. We have calculated mean and standard deviation. Now we will have to take mode. Mode means maximum repeated frequency in the distribution, right? So what is the maximum repeated frequency in this distribution here is, you will have to see the size. So most frequently occurred frequencies is 25. So here you have 125 is there, 225, then 3. So we have repeated frequency, that is 25. Hence we will have to take them as mode. Okay, so mode is equal to 25. As the size of the item repeats 3 times in the size, then you can take the obtained mean value, that is 24.78 minus 25 by 6.3. So you will have to get minus 0.22 by 6.3. So finally you will get minus 0.03. So this is the Karl Pearson coefficient of skewness. Yes, let us see another example, that is with the frequency values. Find the coefficient of skewness from the data given below. So here you can see size and frequency is there. Okay. You will have to calculate d value, d square, fd square. So for that you can take this size and frequency as it is. I have already written here size and frequency. Let us calculate the deviation from assumed mean. I am going to take 6 is the assumed mean. So take 6 is assumed mean and calculate the d value. So that is 3 minus 6, 4 minus 6, 5 minus 6, like that. You will have to get the values minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Then you can take the square of them, that is 9, 4, 1, 0, 1, 4, 9, 16. Now you can take the multiplication between frequency and d value, that is f into d, 7 into minus 3, 10 into minus 2, like that you will have to check the values. So we will have to get the values like minus 21, minus 20, minus 14, 0, 102, 272, 129, 32. So after calculation of fd, you will have to calculate f into d square, that is 7 into 9, 10 into 4, 14 into 1, like that. You will be getting the values like 63, 40, 14, 0, 102, 544, 387, 128. Now we will have to take the total of the frequency, that is capital N or summation f, 355. At the same time you will have to calculate the value of summation fd, that is 480, and summation fd square is 1278. Now we will have to consider this summation fd and summation fd square in order to calculate mean and standard deviation here. So here you have mean formula, x bar is equal to a plus summation fd by n. Take a is assumed mean, that is 6 plus summation fd is 480 divided by capital N is 355. So 6 plus 1.35, you will have to get 7.35. So this is the mean value. Now we will have to take the mode value here. How will you take the mode value when you have frequency? Let us see here. So we will have to take highest frequency value here. Which one is the highest frequency value? 136. So we will have to consider corresponding x value is the mode. That is, if we consider 136 is the highest value among these frequency values, then corresponding x value is 8. So that 8 is nothing but mode here. Take mode is 8, then you can calculate the standard deviation value. So summation fd square is 1278 by 355 minus 480 by 355 whole square. Take the square root of 3.6 minus 1.82. You will have to get square root of 1.78. So after taking square root, you will have to get the value is 1.33 for the standard deviation. Now you can calculate the coefficient of skewness. Then for that, formula is mean minus mode by standard deviation. Mean value is 7.35, mode is 8, standard deviation value is 1.33. So you will have to get 0.65 in the numerator by 1.33. So finally you will have to get the value for coefficient of skewness is minus 0.5. So this problem belongs to the continuous series under the coefficient of skewness. Let us see this example. Find Karl Pearson coefficient of skewness for the given distribution. Here we can see x in the previous example we have it in the discrete form. So in this problem we have x variables in the continuous form, that is class intervals will be there 0 to 5, 5 to 10 like that. So corresponding frequency values you have. So under this you will have to calculate mean, mean, mode and standard deviation values. Let us calculate the mode first. So mode lies in the 20 to 25 groove which contains the maximum frequency. So as I told you, we will have to take the highest frequency value here. So which will be the highest frequency here? 21. So take corresponding frequency x variable here, 20 to 25. So the mode will be existed between 20 to 25. Let us calculate that particular value by using this formula. So mode is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into C, where L is equal to, you will have to take the lower limit, that is 20 of this highest frequency, 20 . Then F1 is highest frequency, that is 21. Then F0 is preceding frequency, that is 13. Then F2 is succeeding frequency, that is 16. And C is size of the class interval. So if we consider this one 0 to 5, difference between 0 and 5 is 5. 5 to 10, difference between 5 and 10 is 5. Like that, if you consider the remaining class intervals, you will be getting 5. Therefore, size of the class interval is 5. Now, you can substitute the values into here. So, take L is 20 plus F1 is 21, F0 is 13 by 2 into F1 is again 21 minus F0 is 13 minus F2 is 16 into class interval size is 5. So, 20 plus 8 into 5 by 48 minus 29. So, if you consider this one here, I am going to take here. So, 20 plus 40 by 13, then if you simplify this one, you will have to get 20 plus 3.08, and finally, you will have to get the mode value, that is equal to 23.08. So, from this, if we consider highest frequency is 21, then corresponding x value, that is 20 to 25, mode will be occurred between 20 to 25, that is 23.08 is the mode value. So, let us calculate the mean and standard deviation values. Before going to calculate mean and standard deviation value, we need FD dash, FD dash square, FD dash square here. So, for that you will have to take x value, that is 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40. So, take midpoint here, that is average between these two, 0 plus 5 by 2, 5 plus 10 by 2, 10 plus 15 by 2, 15 plus 20 by 2. Like that, you will have to take the midpoint. You will have to get the values like 2.5, 7.5, 12.5, 17.5, 22.5, 27.5, 32.5, 37.5. Here you can write down the given frequency value, it is in the question only, that is 2, 5, 7, 13, 21, 16, 8, 3. Now you can take the deviation, that is d dash here is equal to m minus, you can assume any value from this m. I am going to take 22.5 is assumed one divided by c, that is 5. You will have to take the class interval size. Take first value, that is 2.5 minus 22.5 by 5, 7.5 minus 22.5 by 5. Like that you will have to calculate here. You must get the values like minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. Then you can multiply this f values with this deviation from assumed mean values. 2 into minus 4, 5 into minus 3, like that you will have to multiply here. You should get the values like minus 8, minus 15, minus 14, minus 13, 0, 16, 16, 9. After this, you will have to square this deviation values, 4 square, minus 4 square, minus 3 square, minus 2 square, like that you will have to take here. So, you will be getting 16, 9, 4, 1, 0, 1, 4, 9. After this, you will have to take f into d1 square or d dash square. So, f into d dash square, that is 2 into 16, 5 into 9, like that you will have to take here. You should get the values like 32, 45, 28, 13, 0, 16, 32, 27. So, let us take the total of this frequency, that is n is 75, then take summation fd square here, fd dash, that is minus 9, then take summation fd dash square, that is 193. So, after this you will have to calculate mean value. So, for mean value, A is assumed midpoint, that is 22.5 plus minus 9, that is summation fd value, divided by 75 is the n value, into c value is 5. Take 22.5 minus 45 by 75, that is 22.5 minus 0.6. So, you will have to get the value 21.9. So, this is the mean value here. So, after that you can calculate the standard deviation, that is square root of summation fd dash square, that is 193 by 75 minus of minus 1 by 75 whole square into 5. You will have to take this 5 out of this square root. So, you will have to get the values is 2.57 minus 0.0144 into 5. So, square root of 2.5556 into 5. Then if you take this square root, then you will have to get 1.5986 into 5. Finally, you will be getting the standard deviation value, that is 7.99. After calculation of mean and standard deviation and mode value, you can calculate the Karl Pearson coefficient of skewness, that is mean minus mode by standard deviation. Mean value is 21.9 minus 23.08 is the mode, divided by standard deviation value, that is 7.99. So, take the numerator value, that is minus 1.18 divided by 7.99. You will have to get the Karl Pearson coefficient of skewness is minus 0.1477. So, this will be the answer for this question. See, in the last slide we have studied about Karl Pearson coefficient of skewness. In that we are going to take all frequency distribution, but in the next type of skewness, that is Bowley's coefficient of skewness, in that we are going to take quartiles, but not all the frequency in the data set. So, here you have a formula for that. You have already studied this one in median mode when you have continuous class interval. So, and quartile deviation too. There we used to study, we used to calculate Q3, Q1 value, isn't it like that? Here also we will have to follow the same formula in order to calculate Bowley's coefficient of skewness. So, here you have a formula. Bowley's coefficient of skewness is equal to Q3 minus Q1 minus 2 into median divided by Q3 minus Q1. So, this is the formula here. You will have to calculate Q1, Q2, Q2 is nothing but median here, and Q3 in order to know the Bowley's coefficient of skewness. Let us see with this example. Find the Bowley's coefficient of skewness for the following series. So, this is individual series or ungrouped data, that is when you do not have frequency distribution. So, for that I have written given data in the ascending order. So, let us calculate the Q1, Q3 and Q2. Q2 is nothing but median. So, what is the formula for calculating Q1? Size of n plus 1 by 4 item. So, here you will have to take the number of items, that is n is equal to 11. So, we have 11 values here. Okay. So, we will have to take that one 11, size of 11 plus 1 by 4th item. So, size of this is 3. Okay. You will, so 12 by 4 you will have to get 3. So, size of third item. So, what is the size of third item here? What is the third item? 6, right. So, Q1 is 6. So, similarly you will have to calculate Q3, that is size of the 3 into n plus 1 by 4th item. So, 3 into again n is 11, okay, 11 plus 1 by 4. You will have to get the value is 9, 9th item. So, here you can take the 9th item, that is 18. This is the 9th item. So, value of Q3 is 18. So, let us calculate the value of median, that is Q2, size of n plus 1 by 2th item. So, size of again n value is 11. So, 11 plus 1 by 2, that is 6. 6th item you will have to take here. What is the 6th item? 12. So, take 12. So, here Q2 is 12. So, from this formula we have obtained Q1 is equal to 6, Q3 is equal to 18 and Q2 is equal to 12. So, after calculation of this, we will have to calculate the Bowley's coefficient of skewness by taking Q1, Q3 and Q2 value, that is median value. You can take those values, that is 18 plus 16 minus 2 into median value, that is Q2 is 12 divided by 18 minus 6. So, you will have to get the value is equal to 0. So, when you say Bowley's coefficient of skewness is 0, here 0, the given series is a symmetrical data. So, when you suppose if you get positive value, then positively skewness. If you get negative value, then it is negatively skewness. If you get 0, then it is symmetrical data, not asymmetrical data. Let us see the another example here. When you have frequency distribution, find the Bowley's coefficient of skewness of the series. So, size and f you have. So, you will have to take size as it is, f as it is, then you will have to consider cumulative frequency here. How will you consider the cumulative frequency here? So, you will have to take 10 as it is for the first row, then you will have to add with the succeeding frequencies. So, take 10 plus 18, 28, 28 plus 12, 50, 50 plus 25, 75, like that you will have to calculate here. So, f and cumulative frequency. So, here you will have to take the values of Q1, Q2 and Q3. Q2 is nothing but median here. So, take the size of n value. So, here you will have to take capital N value. Yes. So, if you consider total frequency of this, that is capital letter F, summation F or capital letter N means 10 plus 18 plus 22 plus 25 plus 40 plus 15 plus 10 plus 8 plus 7, you will have to get the value summation F. Here I have written here. So, at the end you will have to get summation F for capital N is equal to 155. So, this is the capital N value. So, take that 155 here, you will have to get 39th item. So, when you say 39th item, here you can see we can't take the 39th item because we do not have 39th item in this data. So, just greater than 39 is which value? Here we will have to see. For that only we will have to calculate this cumulative frequency value. Just greater than 39 is 50, right? We will have to take the corresponding value, that is 5. So, that is the item here. Okay. So, size of 39th item is 5. Okay. Then similarly here you will have to take Q2, size of capital N by 2th item, take 155 plus 1 by 2, that is 78th item. So, again you will have to take the cumulative frequency here. So, which will be the just greater than 78, we can't take 75 because it is less than 78, we will have to take just greater than 78, that is 115 here you can see. Now, you can take corresponding value of this, that is 6. So, 6 is the value of 78th item. Okay. So, 6. So, Q1 is 5, Q2 is 6. Let us calculate the Q3 value. So, for that you will be having formula size of 3 into capital N plus 1 by 4th item, take 3 into N is 155, you will have to get the value is 117th item. So, here you will have to find out that one, just greater than 117. So, just greater than 117 is 130 here, isn't it? Here you have 115, we will have to take 117. So, just greater than 117 is 130, take corresponding value of x, that is 6.5. So, that will be the Q3 value here. Okay, Q3 is equal to 6.5. After calculation of Q1, Q2 and Q3, you can calculate the Bowley's coefficient of skewness. Here median is nothing but Q2. Take the values here, 6.5 plus 5 minus 2 into 6 by 6.5 minus 5. So, in the numerator 11.5 minus 12 by 1.5. So, we will have to get minus 0.5 by 1.5. At the end coefficient of skewness is minus 0.33. So, it is negatively skewed. So, let us see the another example here with respect to the continuous class interval. In the previous example, we had taken discrete series, here we have continuous series. So, calculate the value of Bowley's coefficient of skewness from the following series. You have wages and number of persons. So, you can take here wages, number of persons and cumulative frequency values. So, for the first one, 1 you can take like that only 1, then 1 plus 3 is 4, then 4 plus 11 is 15, like that he will have to take here. So, 36, 79, 111, 120. Okay. Then here you will have to take capital letter N, that is summation of F I am going to write it here, summation f r capital N, that is total of this column is 120. Let us calculate the Q1, Q2 and Q3. Here we will be having different formula when you have continuous series. So, for that you will have to take n by 4 now. So, take n by 4, 120 by 4, that is 30. So, here you will have to see the here you will have to take just greater than 30. So, just greater than 30 is 36. So, you will have to take the corresponding value of this, that is 40 to 50. Okay. Then f value is that is f1 value is 21 and m1 value is preceding frequency, cumulative frequency, that is 15. So, take class here 40 to 50, then L is lower limit, that is 40, M1 is preceding frequency, that is 15, F1 is corresponding frequency 21 and C1 is 10, because you have class interval size is 10, means here you have 10 to 20, 20 to 30, 30 to 40 is there, right. So, difference between class interval is 10. So, after that you can calculate the values here. Therefore, Q1 is equal to take 40 plus 30 minus 15 by 21 into 10, take 40 plus 150 by 21, then 40 plus 7.14. So, finally, we will have to get 47.14 for Q1. Similarly, for Q2 it is median, you will have to calculate n by 2 first. So, if you take n by 2, that is 120 by 2 is 60. So, here what is the class interval? Median class interval is just greater than 60. You will have to take the cumulative frequency here. Just greater than 60 here is, just greater than 60 is 79. So, 79 corresponding class interval is 50 to 60, then F1 is 43 and M1 is preceding one, that is 36. So, take class is 50 to 60, then L is 50, M is 36, L is 43, sorry, F is 43 and C is as usual, that is 10. You just substitute the values. So, 60 minus 36 by 43 into 10, for 50 plus 240 by 43. So, 50 plus 5 plus 58. So, finally, we will have to get Q2, that is median value is 55.58. Okay. Similarly, we will have to go with the Q3. So, in order to calculate Q3, we must know about 3 by n by 4 value, that is 3 into 120 by 4, that is 90. So, here in the cumulative frequency, you will have to take just greater than 90. So, just greater than 90 is 111, take the corresponding class interval 60 to 70, then F1 is corresponding frequency, take preceding value, that is 79 is M1 here. So, class is 60 to 70, L3 is 60, M3 is 79, F3 is 32 and C3 is 10. So, here it is 2 for Q1, L1, M1, C1. Then for Q2, L2, F2, C2 and M2 you have. So, for Q3, L3, M3, F3, C3, like that you will have to take here. So, after that you will have to substitute the values here. So, 60 plus 90 minus 79 by 32 into 10, take 60 plus 110 by 32. So, 60 plus 3.44, that will give you 63.44. So, now we have got the values of Q1, Q2 and Q3. Let us substitute all these values into the Bowley's coefficient of skewness here. So, here I am going to take the numerator and denominator value. So, Q3, Q1 and median value here. So, in the denominator 63.44 minus 47.14. So, you will have to get 110.58, 111.16 by 16.30. So, in the numerator 0 minus 0.58 by 16.30. So, you will have to get the value is minus 0.0356. So, this is the Bowley's coefficient of skewness, that is negatively skewed, this one has we got negative value. So, next one is last measure of skewness. So, it is based on moments here. Okay. So, based on moments, so that is beta 1 is equal to mu 3 square by mu 2 cube. Okay. So, let us take this simple example in order to know what is moments here. So, calculate the first 4 moments from the following, also calculate beta 1. So, here you have x and f variables. So, you will have to calculate x and f, it is already given in the question. Calculate fx, then d, f into d, f into d square, f into d to the power of 3, that is d cube, then f into d to the power of 4. Okay. So, let us calculate fx, that is x into f, okay, here. So, 0 into 5, 1 into 10, like that you will have to calculate here. So, why do we need to calculate this fx means we will have to identify this x bar, okay, that is why. So, if we take that value we will have to get 0, 10, 30, 60, 100, again 100, 90, 70, 40. Calculate summation f, or you can also call it as capital N. You will have to get 125. Then summation fx value is 500. Now, you can take this fx value and this summation f or n in order to calculate x bar. So, take 500 divided by 125. You will have to get the value is 4. Okay. So, take that x bar is equal to 4 here, take x bar is constant and you will have to calculate d here, that is x minus x bar, take 0 minus 4, 1 minus 4, 2 minus 4, like that you will have to calculate here. So, you will have to get the values like minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So, summation D is 0. Now, you can calculate F, okay, this F into D. So, minus 20, minus 30, minus minus 30, minus 20, 0, 20, 30, 30, 20. So, you can take summation FD, it is also 0 here. Take FD square, you will have to take D square twice, means minus 4 into minus 4 into 5, minus 3 into 10, minus 2 into 15. Like that you will have to do it here. You should get the values like 80, 90, 60, 20, 0, 20, 60, 90, 80. So, summation FD square value will be 500. So, after this you will have to calculate FD cube. So, you will have to multiply this value by 3 times, minus 4 into minus 4 into minus 4 into 5, minus 3 into minus 3 into minus 3 into 10, like that you will have to calculate here. You will be getting the values like minus 320, minus 270, minus 120, minus 20, 0, 20, 120, 270, 320. So, summation FD cube is also 0 here, okay. So, finally, we will have to calculate FD to the power of 4. So, FD to the power of 4 means you will have to take 4 times this one, minus 4 into minus 4 into minus 4 into minus 4 into 5. Similarly, minus 3 into minus 3 into minus 3 into minus 3 into 10. Like that you will have to calculate here. You must get the values like 1002, 80, 810, 240, 20, 0, 20, 240, 810, 1820. So, summation FD to the power of 4 is 4700. So, these are the values. Let us calculate first 4 moments, that is mu1, mu2, mu3, mu4. So, formula for mu1 is summation FD by n. What is summation FD? 0. 0 by capital letter N is 125. So, 0 by 125 is 0. Then mu2 is equal to summation FD square by n. So, summation FD square is 500. So, 500 by 125. So, you will have to get the value is 4. Then mu3 is equal to summation FD cube by n. FD cube is 0. Summation FD cube is 0 by 125 is equal to 0. Okay, then mu4 is summation FD to the power of 4 by n, that is 4700 by 125, that is 37.6. So, these are all the 4 moments, first 4 moments. After calculation of moments, you can easily calculate the beta value, that is beta 1 value, mu3 square divided by mu square cube. Take mu3 square, that is 0, 0 square by mu2 cube, that is mu2 is 4, 4 cube. So, when you have 0 by any values, it will be 0. Therefore, beta 1 is equal to 0.